Someone with little to no experience when it comes to doing any sort of video analysis or real-time video inferencing, or also known as computer vision, this little discussion is supposed to act as a way for me to do a bit of research, share some of the research, and kind of convince myself that I do understand a bit of how to how to get started with video analysis. So let's start off with what a video is. So what is a video? A video essentially is a sequence of images. So let's say we have this is an image of someone standing, and then this is another image. This is image one. This is image two. We can see that the person maybe has moved up a bit, and then this is image three, where the person is back where they initially started. So this basically is a video of someone jumping up and down, but on a first principle basis, but on a root basis, a video is just a collection of images which are played to us very fast. So when we say played to us very fast, we are essentially referring to something called frames per second. To any computer geeks, to anyone that's familiar with monitors or sort of video, has worked with video, they understand what FPS or frames per second is. Essentially, frames per second are basically the metric we use to see to kind of understand how many of these images we can see per second. So for a 30-second clip that has been recorded at a frame of, let's say, 30 FPS, this would mean 30 times 30, I think it's 900. 30 times 30, 900. So this would mean we have essentially 900 frames to work with. Now, how to do this? Because 900 is quite a bit, and if we just take this video, for example, right here, let's say it's a 30-second clip of someone jumping up and down. In a single image, there is a lot of information, and from going from one image to the one frame to the next, there's also a lot of information there. So that little bit of information, which is associated with moving from one frame to the next. So basically, this happens in the first second. This happens in the second, because any any video has time associated with it. That is known as the temporal information. And so how do you account for the width, height, the temporal information, and width, height, and I guess channels and anything else, and all that sort of stuff, all so fast without having any sort of lag or any sort of errors in it? So that is one thing that I'm kind of curious about. After doing some initial research, what I've realized is that parallel computing is the best way to go about this. So essentially, you have a video coming in, and you split up the video, or I guess the processing, across multiple GPUs. This way, you can do this entire process, any sort of processing, a lot faster. And so when I say processing, what do I mean? So this processing could be detecting the human being that's jumping in the video, detecting if there's any sort of issues going on with the video. So like for a real business use case that comes to my mind when I'm talking about this is, let's say if you have a CCTV camera and you have some sort of built-in AI model inside it, where it's supposed to always keep a look. It's looking at kids, and if any time a kid has, let's say, some dangerous or harmful object with them, the CCTV camera can start just going bazookas and letting anyone around them know that, oh, this kid is in danger. So what I just mentioned, basically singling out a specific person in a video or a specific object in a video, is called segmentation, or basically object detection. And so how does that work? So let's go back to our image right here. I wonder if I can copy this and just move it down. Perfect. So yeah, let's go back here. So let's say, how would we go about detect how would we go about primarily just classifying this individual, that this just tracking this individual and what this individual is doing. This can be really useful for sports. So to go about this, so let's forget this is a video. This is just an image. In order for us to do this in an image, we would basically have a CNN. We would have a CNN basically go in and figure this out. And in order for the CNN to be good, we would need a bunch of images that already have this labeled. So this bounding box has already been created and it has been labeled as a person, a person, a person, a person. So like a billion of these persons, per people, or persons, I guess. So we can basically take that concept over to computer vision or any sort of video analysis where given per frame, we basically try to create per frame we try to create this bounding box constantly around the person we want, or I guess our y value, or the value that we're trying to predict. And so, but is it the same CNN? Not necessarily, because now we're dealing with 3D images. These are 2D images, but then there's something called a 3D CNN, where so a quick overview would be, so we have, this would be a CNN. So I'm just gonna quickly draw the pixels, or I guess this is a really poor drawing, but it will get the job done. And then so we would have a convolutional layer that would come in here and basically just go all around, making a smaller convolution or kernel right here. This right here is 2D because it only has a width and a height, but then a 3D CNN would have an additional layer. So RGBs in 2D images are kind of treated as 3D CNNs, but then it can be neglected because we usually grayscale images. But then for MRIs, X-rays, or any sort of 3D medical imaging, we cannot necessarily get rid of the depth or the volume, I guess, in that context. That is important information. So similar to videos, for us, that important information would be temporal information, because for some reason, let's say if we just don't look at this, or don't take the fact that from second 1 to second 2, this object has moved. Then if we just compare this human's location from second 1 to second 3, it's the same. So that means we could potentially just say that nothing happened, but that's not true. It did move. So that's why the temporal information is very important. I have yet to kind of do a deep dive and understand how these 3D CNNs do a really good job at making sure this temporal element is very well secured and like retained. Another thing that I kind of came across is something called optical flow, where you kind of do this bounding box, then you kind of classify what object you want to do any sort of detection with, and then you use vector math to kind of predict where it will move. So you have some initial, so you have this ball, let's say that's bouncing up and down, up and down, right? And so what you can essentially do is, once you have this bounding box created around this ball, and you've constantly and it's doing a really good job at keeping it within that, so and your bounding box is doing a good job at tracking it all throughout, you can essentially use some mathematical formulations, which I don't fully understand yet, but on a high level, it's called optical flow, where you can basically vectorize the movement of this ball. And so as you can see, it's kind of moving in this pattern, and so you can kind of use the mathematical formula to kind of predict that, hey, it's going to move this way. So this, what it tells us, that we can essentially have, if we have, let's say, 100 frames of this, we may not need the 110th, because we know that in the last 100 seconds, it has been bouncing up and down. And so in the 110th frame, it may do the same. It may be up, it be up, or it may be down. So some other things that kind of are very important when it comes to video processing is live inferencing, and how to do it very fast. So NVIDIA has some techniques that they use, but I think it mainly all of these mainly come down to very good hardware. So let me just write this down. So live inferencing is what we mainly care about when it comes to computer vision or any sort of video analysis. So main thing is really good hardware. I don't think there's a way around it. We can kind of do a way analysis on, do we care about, how much do we care about speed? So speed versus accuracy. Sometimes accuracy is not that important because we are okay with having a lot more false negatives, but we just want something out there. So speed versus accuracy and parallelization. So it's making use of your hardware to kind of the spread the work horizontally. Let me just make sure I go through my notes to not see anything. But yeah, other ways to make this, I guess, a lot faster is using these optical flow techniques where you don't necessarily have to process every single flow, doing parallel computation with using temporal context, and so basically doing optical flow where you can kind of guess or predict where the next thing is going, using recurrent neural networks where you can kind of use the previous frame. Again, kind of the same thing as optical flow. Yeah, so this by no means is an in-depth or a good introduction to how to work with video or get introduced to computer vision, but it's more so what there is to all of this, and we can kind of understand how much work and how much in-depth understanding there needs to be to do any sort of real inferencing on videos or doing computer vision. So yeah, thank you.